action movie, but some scientists claim with our current technology, this may be a possibility in the very near future. Professor Sergio Canavera is one of the leading minds behind this radical leap in medicine. His outlandish experiments have garnered both fame and harsh criticism by his peers. These include the full head transplant of a corpse and the grafting of a mouse head onto the body of another, in which this strange hybrid lived for 36 hours. His next step is to attempt head transplants on patients in China. This week, the research team will be presenting their findings at a conference in Korea University, Korea. We'll cross live to this monumental talk.
Thank you. I'm here at Korea University in Korea, where the findings of the team's most recent experiments are being presented. The procedure uses a fusogen called Texas PEG. A string of papers published in Science Neurology International have apparently shown that this injury can be repaired using Texas PEG. This process is said to repair the circuitry and allow for impulse conduction down the neuron. This allowed rats with severed spinal cords to regain motor control in 3 weeks. A few short years ago, this would have been deemed impossible.
In this video by the researchers of Korea University, we see a beagle regaining motor control 3 weeks following an upper spinal cord transection. It was treated with polyethylene glycol, or PEG. The research claims that PEG treatment allowed the beagle to regain 90% of motor and sensory ability and live a normal life. However, greater histological evidence is required to review the extent of cellular repair.
Can Dr. Canavera really use this information and apply it to human head transplants in the future? We can only wait and see as researchers continue their study into spinal cord repair.
We now have an exclusive telephone interview with Dr. Canavero. Hi, Dr. Canavero. It's great to have the opportunity to speak to you today.
Ciao, I'm so glad you want to learn more. It could be you that needs a head transplant one day.
So, a big question is, how are you going to detach a head from a body?
My good friend Farida Marouche, he's a professor of mechanical engineering and bioengineering, and he's one of the best you'll find. What he's done is he's developed a smart surgical cutting device system made of a diamond microtomic snare blade, which is referred to as a nanoknife. This procedure needs to be treated delicately and with the utmost care, since it hasn't really been achieved before. Ultimately, we want to minimize damage and scarring of the nerves, so we need a clean cut per se. The cuts need to be precise, the micrometer or the nanometer. Depth, speed, angulation and precision are all things we must factor into this procedure, and this can be achieved by the nanoknife. All these little details maximize the regeneration along the nerves.
How will you glue the head back on the body?
Oh, no, we aren't gluing. This is a highly intricate procedure.
When the nerve is cut, a signal cannot propagate along an axon. Only 2 minutes after the Texas PEG is applied, the membranes of several severed myelinated axons are fused together. PEG is a nano-enhanced form of polyethylene glycol. It repairs the phospholipid bilayer and is hydrophilic, meaning it is soluble in water. When applied, dehydration of the plasma membranes occur to allow the protein, glycoprotein, and lipid structural elements to resolve into each other. Rehydration after the PEG is exposed promotes the polar forces associated with the water phase to reassemble the structure of the transmembrane elements. Virtual reality programs which will engage them in bodily movements and provide realistic sensations when carrying out conventional motor activities.
Thank you for your time.